Hello, this is Ms. DB. Now we're going to move on to something that's a little bit more challenging when working with matrices, and that is multiplying them. You do not just multiply the corresponding entries like you did for adding or subtracting. So it is a little bit more complex, but we will work through it. We will only multiply matrices that have fairly small dimensions, like a 2 by 2 or smaller even. If we get bigger than that, like a 3 by 2 or 3 by 3, we can use an online calculator or your graphing calculator. So we'll use technology to multiply matrices. So you already multiplied by a scalar. That's different. That's when you have a number in front of the matrix, remember from 4.1, and then you multiplied every entry by that number. So this multiplying by a scalar would result in the matrix 6, 24, 3 times 5 is 15, 3 times 7 is 21. When you multiply two matrices together, it will look like this. 3, I'm just making up some numbers here. So when you're multiplying two matrices together, there's certain rules that you have to have. And I covered up the rules area. That's all right. So first of all, matrices A and B can be multiplied only if there's a certain thing about the dimensions that has to be true. The number of columns in A equals the number of rows in B. Now remember, when you talk about a matrix, we name a matrix by its number of rows first and its number of columns second. So this would be a 2 by 3 matrix. The number of columns in matrix A has to match the number of rows in matrix B. So this would be a 3 by 2. So this one has 3 columns, this one has 3 rows. Those two things have to equal each other in order to be able to multiply these. In order for multiplication to be defined for matrices, that has to be true. When you multiply a matrix that has an m by n dimension by a n by p, see the n and the n is the same in both of them, the result will be an m by p dimensions. So this one up here, this example up here, when I multiply these together, I will get a 2 by 2 matrix because the 3's match and you're left with the 2 rows by 2 columns. Here's an example of a different two matrices that you would be able to multiply these, because matrix A is a 2 by 3, matrix B is a 3 by 4. These two parts match. Those have to match. The number of columns of the first has to match the rows of the second. And then you would result in a 2 by 4 matrix, the parts that are left. Now you would not be able to multiply B times A, because that would be a 4 times 2, or 4 times 3, sorry. B is a 3 times 4, and A is a 2 times 3, 2 by 3, sorry. And these two do not match. So you could not multiply these in the other order. Multiplication in matrices is not commutative. In this example, C is a 3 by 2, and D is a 3 by 1, 2, 3, 4, 5. These two numbers do not match. Therefore, you could not multiply these two matrices. Not in this order anyway. You could check and see if you can multiply them in the other order. DC might be defined, but CD is not defined. So always check that. Check that before doing any work. M by n matrix A can be identified by using the notation A times m by n. That's just talking about notation there. This is a one way of remembering. It's a mnemonic device. It says car, columns as rows. Columns of A has to match rows of B. So if the columns as rows are the same, or matrix product AB won't even start. So the car won't start. That's the way to, one way of remembering it. this is on your worksheet. It just is a reminder for you of what we just talked about, kind of a summary of when you can or cannot multiply matrices. All right, so on this one, we're going to see if we can or we cannot multiply these matrices. So they're not even showing us what the matrix of A is or B. They're just telling us what its dimensions would be. So if A is a 3 by 4 and B is a 4 by 2, could you multiply A times B? Make sure you look and see if it's AB or BA and write it in the same order. Well, because the 4 matches the 4, so columns and rows are the same, then the car will start. So we are able to multiply these two matrices. Oh, and we're also supposed to say it's new dimensions, and the new dimensions would be this outer part. It'll be a 3 by 2. All right, let's look at another one. So they want to know, is CD defined if C is 1 by 4 and D is 3 by 4? Here's C, 1 by 4. D is 3 by 4. The 4 and the 3 are not the same. The rows, the columns of the first does not equal the rows of the second. So it is not defined. Could not multiply those. All right, how about QP? For Q, we have a 5 by 3. P is a 2 by 5. The 3 and the 2 are not the same. So this is not defined. You could not multiply those together. All right, same matrices. Look at S is a 4 by 5 and R is a 4 by 3. 5 and the 4, the columns of the first is not equal to the rows of the second, so it's not defined. If just as you look across the columns of A and down the rows of B to see if a product of A, B exists, you do the same to find the entries of a matrix product. All right. Here we go. Now, if you can multiply, if it is defined, this is how you multiply matrices. And there's notes on your worksheet so you can refer back, but this is what you're going to do. It's a many-step process. We're going to be multiplying a 2 by 2 matrix by a 2 by 2. So because the 2 and the 2 matches, we'll be left with a 2 by 2 matrix. All right, so our matrix P is, matrix P is equal to matrix A times matrix B. So if you're going to be multiplying these two matrices, what you do is you start with the first row of your first matrix, and you're going to be working with your first column in your other matrix. You're going to multiply the first number in the first row by the first number in the first column. And that will be part of your first entry. And then we will add to that the second number in the first row by the second number in the first column. So 2 times 7. So we're doing everything in this row multiplied by everything in this column. And then we add those two numbers together. So 1 times 5 is 5, plus 2 times 7 is 14. So our first entry will be 19. Now this one you do need to write some stuff out. It's really hard to do all of this math without putting anything down on paper. It's very complicated to put all of this just in your head. All right, now we're going to go to the second entry. So remember, that's just the first entry. So the second entry is going to be the first row again by the second column in the other matrix. And then again we go 1 times 6 and 2 times 8. And this gets easier with practice. 1 times 6 is 6. 2 times 8 is 16. So our second entry would be 22. And then we are done with the first row. We did the first row by everything, right? So now we move to, did you guess where we'd go next? We're going to go to the second row, and we'll multiply that by, first by the first column and then by the second column. So 3 times 5, and then 4 times 7. So we'd have 15 plus 28. These are some big numbers. 15, 28, 43. And then we do the second row by the second column. So 3 times 6 and 4 times 8. So 3 times 6 is 18, 4 times 8 is 32. Add those together and we get 50. 50. And there's our new matrix. It is a 2 by 2 like I expected. And that's how you multiply matrices. Remember, we're only going to be doing this with smaller matrices, and when we get bigger ones, we will be using a matrix calculator because of all the calculations involved. All right, so before you even start, we're going to check the dimensions. So this W matrix is 3 by 2, and we want to multiply it by the X matrix, which is 2 by 3. So the 2's are matching, and we'll end up with the 3 by 3 matrix. So we are going to first multiply, here's our two matrices. We're going to multiply this row, oops, I started to circle a column. I said row, but I started to circle a column. This row by this column, and that will go right here. So we take 3 times 4 plus -2 times 5. So 3 times 4 plus -2 times 5. That's 12 plus -10. That's where they got the 2 from. Then we're going to take the first row times the second column. And we'll take 3 times 7 plus -2 times 1. And that'll go here. And then we'll take the first row times the third column. And we'll take 3 times -2 plus -2 times -1, and that'll go in that third spot in the first row. Okay, so there's our first calculation. That's how they got the 2. The next calculation, which we talked about, 3 times 7 plus -2 times 1, would be 21 plus -2 is positive 19. Then we have 3 times -2. Remember, we're taking this times this, and -2 times -1. So we'd have -6 plus 2, because -2 times -1 is a positive 2, so that's -4. Now we move to the second row in the first column. So 1 times 4 is 4 plus 0. That's always nice when you have a 0. That's just 4. Then we're still on the second row, but now we move to the second column. 1 times 7 plus 0 again, so that's just 7. And then 1 times 0, and 1 times -2 plus 0, so that's -2. All right, we're almost done. We're ready for our third row times our first column. So 2 times 4 is 8, plus -1 times 5 is -5. And 8 plus -5 is 3. And then our third row, second column, gives us 13 because we have 14 plus -1. And then there's our last entry would be, remember, we take the first of the first plus the second of the second, and we would get -3. -4 plus 1 is -3. All right, this is the one I like the best. There's more than one matrix calculator out there. There's also a video in your folder about how, if you already have a TI-84 or TI-83, then use that if you want. You enter your matrices into your graphing calculator, and then you can add, subtract, multiply, find the inverse, do all the stuff we're going to be doing with it. This matrix calculator, I'm going to click on it, and it'll take me to the place on the web where this is. And you can see that you can change your dimensions of your matrix by just sliding on this. And you can change them however you need to. Now, can we multiply AB? Try it. It'll say it doesn't work. A's columns must equal B's rows. So maybe I could multiply, let me change this to a 3 by 3. And then when I multiply AB, now this is just going to be 0, 0 because I have all zeros. But it gives you the answer down here. So you replace your matrix up here with whatever your values are on your problem, and then you're able to, you can also check your adding and subtracting. You can check multiplying. You can change A to B like this. It just flip-flopped them. So now if I needed to multiply AB and BA, now I can check and see if I can do both. Oh, can't do both. You can take A squared if it's possible. It's not always possible. And you can do these other things here that we'll talk more about as we continue on in this chapter. Learn how to multiply matrices this long way by hand with a 2 by 2. But if you get matrices that are larger by a 2 by 2 and you want to use the matrix calculator, then I am totally fine with that. This is just another example. If you want to check how this is done, pause the video and you can go through how they got each entry. In this one, they ask us to multiply x times y, and the number of columns in the first did not match the number of rows in the second. So this one you would just say could not be multiplied, or multiplication is not determined. This is an example of a real-world situation where you might need to do that, multiply matrices. We've got two different matrices here. We've got a sales price of videos and DVDs, and then another one that says how many videos and DVDs were sold on different days. So if we wanted to find how much were sold at the two different stores for each day, we could multiply the matrices together. And these numbers are a little bit larger, so you would definitely want a calculator. I would probably recommend using a matrix calculator or your graphing calculator to double check all of these numbers as you go, or to enter the matrix of each in and then use the multiplication key to go ahead and multiply these together. So you would end up with this matrix, and then you would need to say, well, what does that mean exactly? This means that Video World made $851.05 on Saturday, and Star Movies made $832.50. So you would be able to identify how much money was made at the two different stores per day. A square matrix has the same number of rows and columns just like you would expect, so like a 2 by 2 or a 3 by 3. The main diagonal of a square matrix is the diagonal from the upper left corner to the lower right. So let's do a 3, 4, 5, 6. Here's a square matrix, a 2 by 2. This is the main diagonal from the upper left to the lower right. The multiplicative identity matrix is any square matrix named with the letter I that has all the entries along the main diagonal equal to 1 and all the other entries equal to 0. So a 2 by 2 multiplicative identity matrix looks like this, 1, 0, 0, 1. A 3 by 3 would look like this, 0, 0, 1. These are both identity matrix. There's more than one because there's different dimension sizes, a 2 by 2, a 3 by 3, a 4 by 4, and so on. But it'll be ones all along that diagonal. Everywhere else will be zeros. Square matrices can be multiplied by themselves any number of times, so you can find powers of square matrices. So you could take p squared, you could take q squared, you could take p cubed, you could take q cubed. That's hard to say. However, they're not super easy or quick to do. You absolutely do not just cube all of these entries. That is not what you do. That does not work. You do not square them if you're squaring. You have to actually multiply them by themselves. So for p cubed, it means this. And you know what it means to multiply. So we would have to multiply everything in this row by this column in order to find what we get for the first matrix times the second matrix, and then we would take that solution and multiply it by the third. So it's going to be several steps. So when we multiply the first p by the second p by itself, p squared, that we get this. Notice that these are not equal to, like 2 squared is not 14. That's not how we get those numbers. And then you would multiply this by, here's p again, in order to get our solution of 64, 0, 74, 27. And I would definitely check this using the online calculator or using a graphing calculator. Let me go back for a minute. So I'm just going to jot this down and then go to the online calculator and show you how we could check this there. All right, so, and again, there's more than one graphing online calculator for matrices, but I like this one. So these were just 2 by 2, so I need to change my dimensions. I don't actually need to fill in the B matrix at all. And it was 4, 0, 2, 3. So there is an A squared button. There's also A to the T. I'm not sure what that means. Oh no, that was something else. I switched some stuff around. So I'll change this back to what I had. This was the problem on the thing. So I'm going to do A squared. Here's A squared, 16, 0, 14, 9. I'm going to now send this to A, 16, 0, 14, 9, and I'm going to change B to my original A. That was 4, 0, 2, 3. So now I'm going to multiply A times B because this was my, after I squared it, that's what I got. So now I need to multiply those two together. And 64, 0, 74, 27 is exactly what we got by going the long way in the lesson. 64, 0, 74, 27. Now the only reason that 2 of these entries are the original entries cubed is because of this 0. If this was not a 0, then all of these numbers, none of these numbers would be the same original values cubed. It just happened that there was a 0 in the original matrix, which simplified it a little bit. This one asks us to do q squared. It's a 3 by 3. It's going to take a while the long way. Using the matrix calculator, you would just enter a 3 by 3 matrix and then click on the A cubed or A squared button, and that would square it for you. And they're showing these screenshots are of a graphing calculator. So first, on a graphing calculator, you first have to enter the matrix and give it a name, and then you can do operations with that matrix. And again, there's a video in the folder that shows how to use your graphing calculator, which is a great tool. And if you're going to be taking the ACT test, you can use a TI-84, so you should learn how to use it for these things. All right, so let's look at a couple problems from your worksheet. Let's do just, let's say number 10. Number 10 asks us to multiply E times G. So E, first of all, we're going to check and see if it's possible, is a 2 by 2, and G is 2 rows by 4 columns. So it is possible because these two numbers match, and our answer will be a 2 by 4 matrix. So we're going to do one the long way, and we are going to multiply. We'll start with the top row times the first column of G, 0, -2, 3, 0, and 5, 0. All right, so here's our method again. We start by taking the entries in our first row of our first matrix by the first column in the second matrix. And we multiply and then add. So -4 times -4 is 16. 1 times 1 is 1. I'm probably going to need a little more room, because my result will be a 2 by 4. All right, then I move to, I wonder if I can erase this column. Yes, I can. Now I'm going to multiply the first row. I have to do the first row by every column, so I'm just moving over. And now I go -4 times 0 which is 0. Zeros are great in matrices. Times 1 times -2, or plus 1 times -2, which is -2. Then I leave my first row till I get all the columns done. Now I go over to the third column and I multiply -4 times 3, that's -12, plus 1 times 0. Oh good, another 0. And then I move my column over, and now I take -4 times 5, which is -20, plus 1 times 0, 0. Great, lots of zeros. Okay, now we're all done with the first row. And I lost my bracket there. So now I'm going to take my second row. Pen. Here's my second row, and I take -2 times -4. Maybe I should use a different color. -2 times -4 is -8, plus 2 times 1. And then I forgot to circle the column that I was working on. Maybe for the sake of time, I'll just use arrows. Now I move over to the second column, and I'll go -2 times 0, plus 2 times -2. 2 times -2. That's -4. And then I move to the third column, which would be -2 times 3, plus 2 times 0. Another 0. And then finally, I'm over to this last column, -2 times 5, plus 2 times 0, 0. Again, zeros are great when you see those in a matrix. So now I simplify. I get 16, -2, -12, -20 for the top row, and -6, -4, -6, -10 for the bottom row. Now, of course, you can check that with the online calculator and see if you made any mistakes, see if I made any mistakes. All right, let's do one more. F. F squared. This is a 4 by 2. Can you square it? No. Not possible, not defined. You can only square a square matrix, a 2 by 2 or a 3 by 3 or so on. E you can square. Now remember, you do not just square the elements in your matrix. That will not work. You have to write the matrix down as it is, and you are going to multiply it by itself. That's what squaring means. This is just a 2 by 2, so you can practice your multiplication of matrices and then check your work with the online calculator or with your graphing calculator. So when you do these problems, first make sure that it is defined, multiplication, in the order that they are listed. Like number 12 is not EG, it's GE. So double check that it works both ways, or if it doesn't, then say it's not possible. Wasn't number 10 not possible? Or was this number 10? This was number 10 that we did. So number 12 then, they're not often commutative. So G would be 2 by 4. And E is 2 by 2. So if these do not match, you just write not defined or not possible. All right, so good luck with this. Take your time, double check your work, and don't take shortcuts that aren't available to you, like just multiplying all the entries by each other. Thank you very much and have a great day.